Picture this. The invigilator announces you have exactly 3 minutes left. You flip the page and boom, a massive multi-part question on checksums and check digits is just staring back at you. If your exam timing and strategy are off, this exact moment is going to cost you your Cambridge IGCSE computer science grade. Let's fix that right now.
You've got 3 minutes left, 6 marks on the line, and despite hours and hours of revision, your mind goes completely blank. You are literally frozen. You know what a checksum is, right? You've read the textbook, but looking at the specific scenario on the page, maybe it's a robotic system or a secure communication network, you just can't figure out how to structure the exact steps the mark scheme is actually demanding. And those 6 marks, they represent a massive jump in your final grade boundary.
This totally highlights a painful learner mistake, memorizing isolated facts instead of anchoring your explanation to the exact scenario given. The principal examiner notes are incredibly clear on this. Listen to this. Generic responses rarely gain full marks. In IGCSE-style computer science, you literally cannot reach the highest band by just throwing down short, disconnected labels. If the context they give you is a school network, an office, a robot, or a database, your answer absolutely must stay inside that context, no exceptions. To fix this, we need an unbreakable system. So let's dive into Section 1, the 4-prompt memory framework. This right here is the reliable memory structure you need to be using. If you can actively answer these 4 prompts out loud for checksums and check digits, you'll instantly transition from giving a vague definition to a high-yielding applied answer. Okay, first, what is it? Well, it's a method of error detection. Second, how does it work? You need to be able to sequence the exact process, like, recalculating a block of transmitted data. Third, where is it used? Think of practical applications here, like a banking or retail system. And fourth, why is it better or worse than an alternative? Seriously, if you can answer these 4 prompts, your knowledge is actually finally ready for the exam paper. Now, in a moment, I'll show you the examiner clue that changes the answer completely. But first, you need the framework that makes that clue obvious. Because without understanding the practical application, you won't even notice the breadcrumbs the examiner is leaving for you right there in the question scenario. Let's look at how this plays out in the real exam hall with Section 2, Spot the Error, Flawed versus Top Band. Check out the contrast here. It's night and day. The flawed answer on the left is a classic generic trap. A checksum checks for errors in data. Yeah, it's true, but it's totally vague and completely ignores the scenario. Now look at the top band answer on the right. It diagnoses the exact demand and anchors straight to the banking context. It uses precise terminology like algorithm, recalculates, and block of transmitted transaction data. This is exactly what examiners mean when they say you must anchor your explanation. So the crucial point here is avoiding these principal examiner warnings, especially mixing up nearby concepts, like confusing validation and verification when you're discussing check digits. Computer science mistakes frequently pop up when learners confuse similar ideas like memory and storage. You might lose marks by naming a method without actually explaining how it works, giving an advantage with no underlying reason, or, and this happens all the time, describing a totally different technology that just sounds kind of related. Your nodes have to be dense and targeted to train you to compare these concepts so you don't fall into these classic wrong turns. Okay, before you write a single word, I want you to pause, look at your exam paper, and predict. Ask yourself, what exactly is this task testing? Is it a process explanation, logical reasoning, maybe binary manipulation? This is a vital practical checkpoint. Is the examiner asking you to evaluate a security method, or are they asking for a hardware or software selection? Once you accurately diagnose the demand of the question, you are far less likely to just word vomit everything you know without any direction. You become a targeted sniper with your marks. To make absolutely sure you never freeze on these questions again, let's move to Section 3. The 3-pass revision cycle. This layered style is vital in computer science because the questions force you to adapt theory to entirely new scenarios. Okay, so pass 1 is your foundation. That's securing your definitions and contrasting things like checksums versus check digits. Pass 2 is practicing the sequence. Can you explain the steps of the process so clearly that another learner could follow it? But pass 3 is where the magic happens. This is where you change the scenario yourself. Mix up similar terms, justify your choices, and force your brain to apply the theory to, say, a smartphone, an industrial control system, or a media processing environment. All right, you now have the ultimate method for securing marks on checksums and check digits. But here's the harsh reality. If your exam time control is weak, even the best framework in the world will not save your grade. Think back to that ticking timer at the beginning.
If you spend way too long diagnosing the context on a simple 3-mark question, you literally won't have the time to execute your beautiful top-band reasoning on those massive 8-mark questions at the end of the paper. If you bleed minutes on early questions, your entire framework falls apart. So you really have to ask yourself, are you controlling the clock, or is the clock controlling you? To fix this critical time control gap, watching our next explainer on examiner report mistakes is your mandatory next step. Click the explainer on screen right now and subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations.